When you repair these clocks, the first thing you need to do is to establish whether the problem is mechanical, with the gears stripped or ganked up, or the problem might be electrical in the connection. The plug may have loose wire, or the coil inside in the motor may have a broken wire, loose connection, and not function properly. And to do it, you just measure the resistance of the coil. And whether you use a nice meter like this Fluke or something very cheap from Harbor Freight, you can do it. I just turn it to, this is manual setting, so this is set to 2000 ohms. And we are going to put these probes across the plug. Stick one probe in one prong of the plug, okay, and stick the other one to the other end. As this is the resistance of the coil, so it's 1655-56 ohms, which seems to be correct for a tiny 2.5 watts motor. Now we can do the same using the Fluke, and in this case we have determined that the electrical circuitry is fine. I have connected the clock to a kilowatt type of device to show the watts that it actually takes. So when we hit the function, it will show 2.3 watts. So that's the power consumption. Then we have the voltage, 123 volts. We have the amps, so it's 27 milliamps AC that it takes, but it is 2.3 watts. Now, I had to change the original plug into this temporarily, and the original plug had what seemed to be a little broken cord in the very end of it. It didn't seem to be right. It didn't make proper connections, so this is the old original little plug. But this will be replaced with something nicer. This is the original motor, Jefferson Electric, and this motor has a gear that's stripped, and this is the little plastic gear right here that has broken teeth. So we see that this is gone. However, I found that you have about the same kind of motor, perhaps with different transmission, different gears, in this kind of a intermatic timer. When you pry loose this large knob and you take this out, there is right here there is a T10 Torx 10 star screw that you have to remove. Then you can pry it with a flat head, and once you remove it, this is the timer motor that's inside. And when you flip it the other way, you can see, compare the size and the shape. These guys look basically the same. The gears will be probably different, so we have, but we don't need to change. These are metal. They're made of brass. They have some old grease which will be replaced with new one, and they're in a pretty good shape, so this should work another 10 years, maybe 20 years. Now to open it up, all you do is grab a flathead screwdriver, wedge it like this, and turn it, twist it. Now we have it, that should nicely open. And when you look inside, we have about the same arrangement. So we have the two gears. If you have problem with these two, they're interchangeable. So this is what these little guys look like. Just remove it. So this is the broken Jefferson, and this is the new one. And now These gears are made of soft plastic, so it's probably to dampen any kind of noises, but they do feel like they're semi-soft. This is not hard plastic, so this is probably to keep it quiet. Here's a comparison of the two motors and the gearboxes, and the motors at the initial part are almost identical. They don't differ that much. However, the gears we can see are different. The Jefferson motor has brass gears, and the Intermatic timer has plastic, and the arrangement is a little bit different. But anyway, if you have a problem with a broken gear, just grab, and you have this kind of a motor, Jefferson this type, then you can use parts from an Intermatic, such that you know which kind. So this is the typical Intermatic timer, and they have inside almost the same kind of motor, different gear arrangement, so you cannot use the gears from the Intermatic, but you can use the rotor and the first gear that goes into the gearbox. These are basically identical, but you can see how the motor can spin either direction. However, you want it to spin in the right direction, and this is what the flag, this little part in the bottom, is for. It will prevent it from going the wrong direction. So just make sure to set it that the motor spins in the correct direction. So this gear has to spin, the first one has to spin clockwise, and the large one on the top anti-clockwise. So this is the proper direction, and that way you will get this bottom gear going this way. You can see how ever so slowly it spins gently, and this will correspond to the gear in the bottom, the large one that turns the glass, and this will be spinning in the right direction of the clock. I have removed most of the old gunky grease, and you can see, just take a look how hard and that thing is. It used to be grease, but now it's just ready to become petrified. So this is all removed, and what I will do is pack it with the white lithium in the gears, and then put the clock together, test it out. But it's very quiet, and these cost about 80 to 100 replacement motors on the internet, so ridiculous prices. So it's worth repairing, and good luck to you all if you try, but this is well worth a repair.